Hello, this video lecture is about topic 1 of the chapter 2, part 1, the graphics and data for univariate distributions. Today we will be talking about frequency distributions. The first one in part 1, that it is really important to express your data. The shape of distributions and accumulating data will be discussed on the part 2. This lecture will cover frequency, grouped frequency distribution, bar graph, histogram, and line graph. At the end of the lecture, you can express which graph is proper to show your data. Just start, it is an important concept to know the frequency and frequency distributions. Frequency is the number of times a data value occurs. For example, in in Nell's data set, one variable is reason. So, if we want to know the frequency of the value for reason, what we are asking how many students lives in these regions: northeast, north-south, south, and west. Frequency distributions displays the number of times a data value occurs and all values for the variable. It is visual representation of data. The frequency distribution can be tables such as the frequency table or percent table, or sum of graphs such as bar chart, pie chart, stem and leaf, histogram, and line graph. Your book shows detailed examples out of this. The frequency distributions are often used to examine data because they are very helpful to understand, to see patterns and trends. Also, they can point out outliers. Frequency distribution provides a lot of information very quickly. The frequency distributions can be used with nominal, ordinal, interval, and ratio scale variables. In general, the nominal scale values use frequency table, percent table, bar chart, pie chart, with the others used in grouped frequency distribution, stem and leaf display, histogram, or line graph. Here is an example of a frequency table for the variable reason in Nell's dataset. You can see the 3 columns. The first is the frequency of the reason, the second is percent, and the third is the cumulative percent. It is an example. There is 150 school students in the south region. So if you look at the reason, the south goes crossed, you can see the 500 students in the column. This represents 30% of the data set. In total, the students from the northeast, north central, and south, the first 3 represents 81.4% of the data. The group frequency distribution, the group frequency distributions are the table frequency distribution. Once to get score intervals, replace actual scores. This just means grouped numeric variables save space that all you have values. This practice saves spaces, but also you lose details. It's important to consider how to select the number of categories. Typically, you have between 6 and 12 categories. You want to make sure that you reduce the data enough to make understandable, but that also retain enough information that it makes sense you look at it. It's important that you look at categories are mutually exclusive and exhaustive. This just means that each piece of data must fall into one and only one category. It's also important that you create categories are of equal size. It is really important. First, here is an example frequency distribution for SES in NEL's dataset. This is not a grouped frequency distribution. Here is a socioeconomic status have been divided by category from 0 to 35. You can see here the frequency, the percent, and cumulative percent. Alternatively, this is the grouped frequency distribution of that same data for SES. Here are looking at the same data representative the other way. Here the value is grouped in 8 categories, and each category represents 5 of those values. For example, the first category is 0, and that represents SES categories 0 to 4 for the previous table. The category 5 represents 5 to 9 previous table. So, as the checked, we can look and see the cumulative percent on the category at 5 is 10.8. And we are talking about here that if we go back to the previous slide, you will be able to see that the cumulative percent for 9 is also 10.8. This is an example of a bar graph of reason in the NEL's dataset. The bar graph used for nominal data. You can see here the variables are on the x-axis. North, central, south, and west are across the x-axis. Frequency, the other words, is the count, is on the y-axis. And the height of the bar reflects the frequency for that category it presents. So, for example, north there is over 100 students. The north, central, and south, there are a little bit bottom of 150, and the west category is least number of students. It's the vertical axis starts at 0. You could also do this as a percentage instead of the frequency. This is an example of the histogram using the SS in the NEL's dataset. So note that the bar touch on the histogram. At the bottom of the bar graph, histogram is used as the continuous data. Finally, this is an example of the line graph of SS data. It's the same data, we are just looking at the histogram, but a line graph. Line graph emphasizes the continuity data and are very similar with histogram. This slide simply shows the summary for you. Compare the bar graph and histogram. You can note that the really type of the data represent the bar graph or represent the histogram. So bar graph is used for discrete or categorical data, but the histogram is used for continuous data. And in the bar graph, bar does not touch, but in histogram, the graph with vertical lines forming the rectangles and touch it. And both of the bar graph and a histogram, the variables on the x-axis and frequency of the score of the person on the y-axis. Also, the vertical axis is y-axis starts at 0. To wrap up the frequency distribution, we will shortly show about stem and leaf. This is another way to represent the count the data. This stem and leaf looks like the percentage who taking the SAT and its state data set. This stem part is the left on the graph, and the leaf part is the right on the graph. To read, consider about the leaf falls in the x-axis. So here, there are 90% student and 93% student in the data.